Welcome to Statistics for April 6th. So what we are going to be talking about today in our brand new unit is this shape right here. You guys have seen it before in this class. You know it as a normal distribution. That's right. We're getting back into some of our mix of statistics and probability. It's not the direction that I had always intended to go with the class right now. But being where we're at, we're getting to this sooner than we would have. I was kind of saving this topic for much later in the year, but here we are. Now, before we really start talking about this, I do want to mention one thing. This week was originally scheduled to be your all's spring break, starting on Wednesday, going to next Monday. Even though we've been quarantined for the last 3 weeks and at home, you guys were never meant to have school on those days. You guys were never meant to work on those days, watch these videos, whatever it is, and I want to maintain that. So we're going to have videos today and tomorrow, but starting on Wednesday all the way through next Monday, we're going to take a break. No videos, have a spring break, enjoy that time. We will come back to videos on next Tuesday. So anyway, I was wanting to talk about this shape here, this normal distribution. What we are going to be talking about in this unit is something called sampling distributions. Now, what is the difference between that and a normal distribution like we had before? Well, previously, what we were doing is we were trying to chart the results to some sort of question we asked or some sort of measurement we made, whatever it was. You probably remember the time we did this with the dice, right? We rolled a bunch of dice, added the numbers together when we rolled 2 of them, and then saw that we had a lot of 7s, some 6s and 8s, that kind of thing, and it went down. And we were just graphing the data that we got. What a sampling distribution instead does is graph the means or the averages of many sampling distributions. So let's say we did all of that rolling of the dice, right? And we got a mean of 7. Now, you should get a mean of 7, and the majority of the time when you do this experiment, you would get a mean of 7. But maybe there's those couple of times you get a mean of 6 or a mean of 8. What this sampling distribution does is it graphs what your mean should be, meaning that the center of it should be the actual mean of whatever it is you're measuring, right? So let's say we're doing this dice experiment. The actual center of this should be 7. That should be the mean if you're rolling 2 dice, because it is the most likely chance you're most likely to get a 7 there, right? That should be the mean. So most times you do this experiment, you roll 100 pairs of dice and add them together. You should get a mean of 7. But sometimes you don't. So what occurs is this sampling distribution graphs what your mean could be, and it tells you how unusual your trial and experiment was. So here's the deal. What we can say is that if we can determine the standard deviation of this distribution, and in this case it's actually not called the standard deviation, but it's called the sampling error or sampling variability, then we can determine how unusual getting a mean other than 7 is. Now, I'm just going to make up some numbers here for us, right, so that we can get the idea of this. Let's say that our sampling error, standard deviation, sampling variability, whatever it is 1. So then that would mean that we have a standard deviation of 1. So we would have 8 for our first standard deviation. We would have 9 for our second standard deviation, and we would have 10 for our third standard deviation. I know I'm going a little off the page here, but I'm going to go on the other side too. We would have 6, we would have 5, and we would have 4. Okay. Now, you may recall standard deviations represent a certain percentage of the data within their boundaries, right? Meaning that 68% of data would be between 6 and 8 in this case. Between 5 and 9 is 95% of data. And within 3, in this case 4 and 10, we get 99.7, so a pretty extreme amount. But sampling distributions are primarily concerned with the 95% of data. To say that a mean of between this and this is within the expectations. 95% of data, or 95% of samples are going to get a mean between these two things. And if you get a mean outside of that range of numbers, and that means you had a really kind of weird data set maybe, or your data set was really unusual, or in some cases of studies and experiments that we may be doing where we're trying to see if there's a change in something. You have a medical test and you're trying to determine, well, did this have any impact? If you get a mean of whatever you're measuring outside of that norm, then that's a reason to say, well, maybe it did have an impact, because we should not be getting a mean, an average of this number under normal conditions. So again, what this is graphing is not actual data numbers or data sets, but means of data sets. So the couple of other terms that I want to make sure we get down today, not only is this called a sampling distribution, because it is a distribution of sample means, but also we want to talk about the term sampling error, that is also known as sampling variability. So sampling error or variability refers to how do I want to word this? So it's the variability or the change that is realistic to see from one sample to another. If you're flipping a coin, right? If you're flipping a coin to get heads or tails, if you flip it 100 times, it's pretty realistic. It's most likely that you should get 50 and 50, right? That's like what would be considered the true mean. Is 50% of them would be heads. However, do you think it's that unlikely for us to get 55 heads? Maybe even up to 60 heads? Or all the way down to 45 or 40? I don't think so. I think that's pretty normal, pretty acceptable, right? That's not that far out of the range of possibility. But if you were to get 25 heads and 75 tails, that may be way outside of the scope of what's realistic. That's where something like this comes in. This graph would tell us what is the normal amount of heads or the expected amount of heads to get on a coin flip. We might see something like 40 down here and 60 off on this side. That normal expected amount, that if you were to do this, you got about a so-and-so chance of getting a 95% chance of getting between these two numbers. And we could actually use z-scores and all that stuff we talked about earlier this year to determine the likelihood of getting something like 45 heads on 100 flips. That's what we're going to be talking about tomorrow. We're actually going to do an example of this with the numbers, with everything. We'll probably do the coin flip example. We'll see. But to get back to what I was saying with sampling error and variability, it is the change or the variability possible or expected within a sample. Whatever is realistic or reasonable to this. So if you have any questions on this, I know it's kind of a new topic, but as with all new topics, and especially ones that we kind of have to tell through video here instead of one-on-one chat, I think we're going to gain a pretty solid understanding of it with practice, with seeing it in use. So tomorrow we're going to do that example that we'll actually find numbers for. We'll do all that stuff. And I think it'll make even more sense then that this is a sample of means, not actually of data. If you have any questions before then, feel free to shoot me an email. Otherwise, I'll see you guys in tomorrow's video.